Hi, Mr. Richmond, and this is your Unit 4.3 lesson summary. Unit 4.3 will be on using formulas to determine terms of a sequence. So we're considering continuing our study of arithmetic and geometric sequences. What we're going to do now is give you an actual rule that you can use to skip ahead and find future terms or previous terms in a sequence. The first one is our arithmetic explicit formula. Now this will look very overwhelming at first. There's a lot going on here. It looks like a really complicated equation. It's actually simpler than it looks as long as you take the time right now to learn the language. So our formula is a sub n equals a1 or a sub 1 plus d times parentheses n minus 1. What does that mean? Well, whenever you see a subscript, we're talking about a particular term. So when I say a sub n, I'm saying what is the nth term? In other words, my unknown term. It could be anything. If the problem said to me, find the 10th term, and I didn't know it, well, my unknown term would be the 10th one, so I would say a sub 10. And whatever answer I get after doing this equation, or this formula, is my 10th term. Okay? Within the formula, though, I have to know the first term to even use it. A sub 1 represents the first term. Okay? D is our common difference. That's what it's adding by or subtracting by in the equation. We learned that already. And n minus 1 is just a part of the equation that we need to solve it. What it ends up being is the previous term number. Okay, so for example, if you ask me to find the 7th term, I'd say a sub 7 equals, this will be the answer for the 7th term, is whatever the first term is, plus the common difference in the problem, times basically one number below what I'm looking for. Since I said I was looking for 7, I'm going to multiply d by 6. Because I'd have to add 6 times to get there. So that's why I always have this n minus 1. Find the 7th term, take the first term, add the difference times 6, because 7 minus 1 is 6. Okay? To help you understand that a little further, here's an example. 2, 4, 6, 8, 10. Okay? That's an arithmetic sequence. It's adding 2 each time. If I asked you, what is A1? A sub 1 would be the first term. So in this pattern, you would say A1 is 2. And I would plug in a 2 for A sub 1. If I asked you just, for example, what is A sub 3? Well, A sub 3 would be the third term in the pattern, which in this case is 8. If I said A sub 4, you could say 10. Now, if I asked you for one that's maybe not here, what is the 7th term? 1, 2, 3, 4, 5, 6, 7. The 7th term is this unknown term. So you would write it A sub n and use your formula to get the answer. Okay? So that's kind of an easy one to see. So 1, 2, 3, 4, 5, 6, 7. So you can see that the formula is not always necessary. I mean, if it's an easy pattern, we can get there quicker. But for a lot larger numbers and patterns, and for some of the more advanced stuff to do this later on, this equation will become necessary. So I know the answer is 14. I'm going to explain to you how that formula works in with that. So if I was doing this pattern, A1 would be 2. My common difference is also 2. Okay? You want me to find the 7th term, well, I have to times that by 6 then, one number before what you're looking for. So my formula would look something like this. A sub n equals 2 plus 2. I'm trying to find the 7th term, so I'm going to multiply that actually by 6. 6 times 2 is 12. 12 plus 2 is 14. So the 7th term is 14. Okay, and you can see that the n's here would have to match. Since I was looking for a sub 7, these two terms would match since they're both represented by n in the equation. Okay? And that matches just logically what it ended up being. So hopefully that helps some. You will later see in a second a sub n minus 1. Well, that just means the term before the nth. So if you ever see this, okay, it's not taking that term and minusing 1. Let's say n was 8. I'd sub in 8. 8 minus 1 is 7. So I'm saying this is really the 7th term. If I said n is 9 now, then that would really be the 8th term. So really just the term before the whatever the n is. Okay, for a geometric sequence, our formula is a little different to calculate. We'll use g instead to represent geometric sequence. Okay, g sub n is the nth term. G sub 1 is the first term in our geometric sequence. So just like this one, we have to have that first term to really get rolling. R will be our common ratio, what it's multiplying by in the problem. And then we raise it to the power of n minus 1, kind of like we did here. But what this represents is repeated addition. If I'm going to add by 2 6 times, that's really just 2 times 6. So 2 times the one before it. If I'm going to continually multiply by 2 6 times, 2 times 2 times 2, that's really 2 to the 6th power. So that n minus 1 is just a shortcut for getting to where we want to be. Okay? After we look at some of the explicit rules, we'll talk about recursive formulas. These are, in my opinion, a little more obsolete because you have to know the number before it. So you can't really skip ahead to a number in the sequence. You can only find the sequence for a number right after it, which is fairly easy already. But so we know it, a sub n equals a sub n minus 1. So in other words, if you're looking for the 8th term, you have to plug in the 7th term first. 9th term, you got to plug in the 8th term here, and then I just add in the common difference. For geometric, if I was going to try to find the 10th term, it would be whatever the 9th term is times the common ratio. If I want to find the 12th term, it'd be the 11th term times the common ratio. So really, if we understand this language, we take the time to study that language, this becomes significantly easier. Okay, let's try some problems. I'll slide the board back and forth so we have our formulas. If you hadn't, I would rewind the film and copy those formulas down. You're going to want those for the test, you're going to want those for homework, and rather than have to dig in the book and try to find it every time, if you have a nice little note sheet for it, it'd be better. So, first example, for each sequence, write an explicit formula, then find the 8th term. So the first thing I have to do, there's 2 different explicit formulas. There's one for arithmetic, one for geometric. I want to make sure I know what type I'm dealing with first. So let's see, it's going from 4 to 12, could add 8. 12 to 36, that's definitely not adding 8, so it's not arithmetic. I get times by 3, and 36 times 3 is 108. So this is a geometric sequence. So I want to make sure I use the geometric explicit formula. G sub n. Okay? I know that because it has times 3. That's what a common ratio would be. So here's our formula. G sub n equals G1 times r to the n minus 1 power. All I need to do now is sub in the correct terms. G1, if we remember back, is the first term in the sequence. That's 4. So G sub n equals 4 times our common ratio, which I'm going to put in parentheses. I always like to put my common ratio in parentheses. That way I make sure I do my exponents first. My common ratio is what I'm timesing by every time in the problem. Well, I'm timesing by 3 every time, raised to the n minus 1 power. Now you notice I didn't have to actually plug anything in for n minus 1 because I need to have a variable in there. The variable will always be n, and that shouldn't really be plugged into until you're trying to find an actual answer. So that is my formula. So you can see it's really not all that hard to make the formula once you know the language of the math here. So that's our formula for an explicit rule for this sequence. Now I need to use that to find the 8th term. Now some of you might go, well Richmond, just keep timesing by 3. And you're right, that would work. Okay, but I chose the 8th term to keep it a little easy for us. If I said 106th term, that's a lot of work now. It's a really large number, but that's a lot of work to times by 3 every time. This formula will let us kind of skip that. So to find the 8th term, I just use the rule I just wrote and change n to 8. And this will find the 8th term. So 4 times 3, I'm going to change the n to an 8. Notice that these always have to correlate together. They were both n in the formula. Now that I'm plugging in, they're both 8. And I'm going to get an answer. Okay, remember, G sub 8 is just the 8th term. So I'm going to bring that down. It's just a symbol for an answer. And 8 minus 1 is 7. So I need to raise 3 to the 7th power. Okay, that's a little big to be doing in my head. So I'm going to pull out a calculator for this part. Make sure you follow order of operations, do the exponents first. 3 to the 7th power is 2,187 times 4 is 8,748. So this would be the 8th term in that sequence. I could also get that by multiplying 108 by 3 until I reach that 8th term, but that's a little long. Formula lets me do it quicker. Okay, let's try a different one. Here, down by 5, down by 5. Down by 5. So the pattern here is they're subtracting 5 each time. That tells me it's arithmetic. So I need to use my arithmetic formula. Let's glance back. A sub n equals a1 plus d times n minus 1. Now I just need to plug the terms in and have my formula. So So I'm going to make a formula to find the nth term. I'm going to plug in A1, which represents the first term, 20, plus D, our common difference. Our common difference is -5. So I could write that in parentheses, -5. I could also just change this to -5, if I want to simplify it that way. Times n minus 1. That would be my formula. Now if I wanted, I also could simplify this, because it does distribute, you can combine some like terms, and you can create a simpler version. For now, I'll leave it like this. So that would be our formula to find the nth term of the sequence. Now I can find any term I want. You want me to find the 8th? Fine. I just change n to 8. You want me to find the 60th? Fine. I just change n to 60. They want the 8th, so let's give them the 8th. A sub 8 equals 20 plus -5 times 8 minus 1. Now I need to follow order of operations. Okay, no need to distribute here yet, because I can just do 8 minus 1 first. 8 minus 1 is 7. Okay, addition and multiplication. So I need to do the multiplication first. -35 times, or sorry, -5 times 7 is -35. And then 20 plus -35 is -15. So the 8th term must be -15. And again, I can verify this since these aren't real large numbers just by continuing. -5 would make 0, -5 would make -5, -5 would make -10, -5 would be -15, and I can get to the 8th term that way as well. Okay, let's move on and look at explicit rules. Explicit rules can be easier to write as long as you can understand the formula and not get mixed up with the language. It says for each sequence, write a recursive formula, then find the missing term. What's a little tougher here is I need to kind of, even though I have this blank term, get a good idea of whether it's arithmetic or geometric. So I went from 64 to something, something to 16, and 16 to 8. Now, it could be -8, because they got from 16 to 8 here, but then if I add 8 here and add 8 here, that'd be 32. So it doesn't quite work to get back to the original number. So I'm going to try something different. Let's divide by 2. That would work here. Might work both ways. It seems possible. So I'm going to try to write this as a geometric and see if it works. So we're going to do G sub n equals, and I need to use my recursive formula now. G sub n equals G sub n minus 1 times R. And G sub n minus 1 I need to plug in for. The R I need to figure out. So since it was going from 16 to 8, they had to times by 1/2. So I'm going to make that R 1/2 and see if this works. Okay? If it does, this will be my recursive formula. But I want to check before I verify that. So this is technically the second term that I'm looking for. So I'm going to plug in a 2 for n. And if it's correct, 2 minus 1 is 1. So G sub 2 equals G sub 1 times 1/2. G sub 1 is 64. And 64 times 1/2 is 32. And let's verify and see. 64 times 1/2 would give me 32. 32 times 1/2 would give me 16. 16 times 8, or 16 times 1/2 would give me 8. So I have found that missing term, which means my formula I wrote works, and I have got a recursive formula. Okay, remember, recursive formula, you just need the term before, so a little easier to write. Let's try the next one. They go from 10 to -30, so they could subtract 40. -30 to something, they could subtract 4, they'd be like 120. Subtract another 40 would be 160. So I'm not seeing that as a commonality there. They could also times by -3, possibly times by -3, that would put them at like 90-ish. Times by -3, that would put them at 270. So it looks to me like it's going to be a common ratio of timesing by -3. So let's use the G sub n formula for recursive. Okay. Yeah, G sub n. So G sub n minus 1 times my common ratio R should be the formula I would want to use here. Let's try it. G sub, we're going to look for the 1, 2, third term this time. So G sub 3 equals G sub 3 minus 1 times R, and R is actually, well, at least we think it is, negative 3. 3 minus 1 is 2. So ultimately, to find the third term, I take the second term, times it by negative 3. The second term is negative 30. So I'm going to do negative 30 times negative 3. Negative 30 times negative 3 is positive 90. And now I want to check. Make sure it's following the pattern. 10 times negative 3 is negative 30. Negative 30 times negative 3 is positive 90. 90 times negative 3 is negative 270, which fits my formula. So the formula must be G sub n equals the term before it times R. And R is actually negative 3. So I'm going to change that to a negative 3, and I have my formula. Okay? Now we can also do that with arithmetic, using the arithmetic sequence formula. Those are a little easier to recognize, but it'd be my A sub n minus 1 plus whatever the D is. So hopefully this helps you. This is definitely a tougher section in the chapter, probably the most important one as far as the whole chapter goes, as far as understanding how these work and how to use these formulas effectively. So really practice this section.